Hello and welcome to this video in which we're looking at group 7 elements. Now a quick look at your periodic table, and I'm sure you know this by now, but this is group 7 over here, and these are the group 7 elements, so fluorine, chlorine, bromine, iodine and astatine. So group 7 elements in this column over here. Now they're known as the halogens, that's a familiar name, and the key feature of the halogens is all have 7 electrons outer shell. Here we've got fluorine, so fluorine's got 2 in its innermost shell, and it's got 7 in the outermost shell. 2 and 7 makes 9, which gives the atomic number there. So to become stable, what they have to do is gain an electron and carry a charge of -1. For example, Br minus, I minus, Cl minus. Now all 5 are nonmetals. They have low melting points, increasing going down the group. If we look at these now, we find that fluorine at the top there is a gas, chlorine's a gas, bromine's a liquid, iodine's a solid, and astatine also is a solid. All have coloured vapours, that means coloured gases. Chlorine and bromine are very, very pungent. That means it's something that causes a sharp or irritating sensation. Really, really bad to inhale those things. And here we have some features of them. So fluorine is very reactive. It's most reactive up here, least reactive down here. It's poisonous, horrible poisonous gas, and it's yellow in colour. Chlorine is a fairly reactive, poisonous, dense green gas. Now, chlorine was what they would use in warfare, particularly World War I in the trenches. Bombs would be filled with chlorine gas and would cause gas poisoning, really nasty stuff. Bromine is a dense, poisonous, red-brown volatile liquid. And finally, iodine is a dark grey crystalline solid or a purple vapour. So you can see there how reactivity decreases going down the group. Now that's the exact opposite of group 1 elements. Remember group 1 elements, alkali metals, their reactivity increases going down the group. With group 7 elements, reactivity decreases going down the group. That's well worth remembering. Now, going down group 7, halogens become less reactive because the outer shell is further from the nucleus, so harder to attract extra electron. Here's fluorine. There's the outermost shell there. That needs one more electron. Well, there's not a great deal of distance there between the outermost shell and the nucleus, so nucleus can easily attract another electron, which means it's very reactive. Compare that to iodine. Now, iodine is 1, 2, 3, 4, 5 shells around it, which means the outermost shell here is a long way from the nucleus. There's much less pull on these electrons here, so it's much harder for iodine to gain the electron. Now halogens are what we call diatomic. So when they're gaseous, it means they go around as paired atoms. So chlorine Cl2, bromine Br2, fluorine F2. So they are diatomic gases. They go around in pairs. Now all group 7 elements, all halogens, react in similar ways. This is because, as we've said, they've all got 7 electrons in their outermost shell. A feature of halogens is they are poor conductors of heat. Like all non-metals, they're poor conductors of heat and electricity, even when solid or liquid. So, yeah, pretty poor there. Now, halogens react with other non-metallic elements, such as hydrogen, to form molecular compounds. So an example here is hydrogen, H2, diatomic. Chlorine, Cl2, diatomic, forms hydrogen chloride, 2 molecules of this, HCl. Now, you may be thinking, HCl, I've come across that before, wasn't hydrogen chloride, it was hydrochloric acid. What's the difference? Well, down here. What's the difference between hydrogen chloride and hydrochloric acid? They both have the same chemical formula, HCl, exactly. But hydrogen chloride is gaseous at room temperature, and hydrochloric acid is an aqueous solution of hydrogen chloride. It dissolves in water into its ions. And that's the difference between hydrogen chloride and hydrochloric acid. Now halogens form ionic bonds with metals. So halogens react with metals to produce ionic salts called halides. So F- is the fluoride, Cl- is the chloride, Br- is the bromide, I- is the iodide. So they change to have this ending IDES, so fluoride at the end. Halogens accept electrons from metals, forming ionic bond and structure. And here we've got an example. So here's sodium has reacted with chlorine. Now one of the sodium electrons in the outer shell here, okay, that's now been got rid of, goes to the outer shell of the chlorine. This now becomes a chloride ion with a negative charge. This, now having lost electron, becomes a sodium ion, Na+, and there's a strong bond there between the two. So example, sodium chloride, which is NaCl, Na+, Cl-. Potassium bromide, that should be KBr by the way, not Cl. So KBr gives K+, Br-. Magnesium iodide, MgI2, Mg2+, plus 2I-. Apologies there for the mistake. Now this is an important thing about displacement. Now let's get this straight. A more reactive halogen, and you know that these guys at the top here, will displace a less reactive halogen from aqueous solution of its salt. Well, so look, so chlorine, how's chlorine compared to iodine? Well, chlorine is more reactive than iodine. Okay, so when chlorine is added to potassium iodide, the chlorine displaces the iodine bit. So you're left then with potassium chloride and iodine. Okay, so chlorine will displace the iodine from potassium iodide because it's more reactive. I'm going to summarise that in this table. Now chlorine, just go back a second. Okay, chlorine, don't forget, is more reactive than bromine, and bromine is more reactive than iodine. So chlorine, which is pretty reactive, will react with potassium bromide, displacing the bromine, so bromine plus potassium chloride. Similarly, chlorine will react with potassium iodide, displacing the iodine and leaving potassium chloride. Bromine doesn't react with potassium chloride because it's less reactive than the chlorine, but it is more reactive than iodine. So when you add potassium iodide to bromine, iodine gets kicked out, you're left with potassium bromide. And iodine, being near the bottom of group 7, very unreactive, therefore there's no reaction with either potassium chloride or potassium bromide. Okay, so those are examples there, what we call displacement reactions involving the halogens. Okay, well that's it for this video. Thanks for watching and listening. I hope you understand more now about group 7, and I'll be back with another video very, very soon. So bye bye for now.